Introduction to working with the mesh. Welcome to NaxToPy. In this video, you'll learn how to work with your model's mesh, access element data, and apply specialized methods to simplify structural analysis. Throughout this tutorial, we'll use a Jupyter notebook, which you can download along with all other materials from the link in the video description. How the model loads in NaxToPy. When you use the load_model function, the model automatically loads elements, nodes, coordinate systems, and connectors. However, materials and properties are only loaded when needed, keeping the process efficient. Accessing mesh data is simple. You can use model properties directly or apply specific methods. For example, you can retrieve elements using the elements property, searching by key or ID. Accessing elements. Let's explore how to access and work with elements in NaxToPy. Method 1, using elements dict. Access the elements as a dictionary using model.elementsDict. Use a for loop to iterate through the dictionary, printing each element's key, identifier, and value, details about the element. 2. Using get_elements. Alternatively, use the model.get_elements method. This typically returns a simplified or processed list or dictionary of elements, depending on how the function is designed. Now we can check the output and we are able to see to get the element ID and the part in which the elements are with both ways. Searching for specific elements. You can search for specific elements in two ways. 1. By key, using elementsDict. Access elements by their keys, such as 399000000. For models with multiple parts, specify the part containing the element, for example part 0. Now we can check the output and we are able to see how we get the element ID and the part in which the elements are. 2. By ID, using get_elements. Access elements by their IDs through the get_elements method. If the model contains only one part, there's no need to specify the part. Now we can check the output and we are able to see how we get the element ID and the part in which the elements is with both ways. Accessing other mesh components. Now we will introduce methods for easy access to mesh components based on their IDs. First method, get_nodes. The method get_nodes is called with a list of IDs, for example, 2, 3. This retrieves the nodes with these IDs from the model and stores them in the variable sum_nodes. Now we can check the output and we are able to see how we get the node and the part in which the node belongs to. Second method, get_coords. The method get_coords gives back the coordinates of all nodes in the model and assigns them to the variable a_coord. Now we can check the output and we are able to see how we get nothing because there is no coordinate system create in this model. Third method, get_connectors. The get_connectors method retrieves all connectors in the model and assigns them to the variable sum_connectors. Now we can check the output and we are able to see the connectors, that is telling us the type of connector that it is and the part to which it belongs. Accessing materials and properties. Materials and properties do not have dedicated methods. Instead, they are accessed through dictionaries containing instances derived from the classes N2P material and N2P property. Model.materialDict refers to a dictionary-like structure that stores the materials defined in the model. We will assign this dictionary to the variable matDict. Model.propertyDict is another dictionary-like structure that stores the properties defined in the model, assigned to the variable propDict. Special methods for mesh analysis. NaxToPy also includes special methods to access elements based on specific characteristics. For example, get_elements_by_face helps you find coplanar elements. Get_free_edges identifies the free edges of elements. Get_elements_adjacent and get_elements_attached help in locating adjacent or connected elements for structural analysis. Working with get_elements_by_face. We will now work with the get_elements_by_face method. 1. Choose a random element, for example, 399000000. 2. Select the domain where you want to look for elements, a domain set in a previous step. 3. Set the tolerance angle that the tool will work with. 4. Now we can see the output. Working with get_free_edges. Next, we will use the get_free_edges method. This method is called from the model. You will need to provide a list of elements, and it will return the free edges. The result will show the element and the nodes that form the free edge. Now, we can see the output, which displays a list of elements and nodes. Working with get_elements_adjacent. Similarly, we will use the get_elements_adjacent method. Provide an element and a domain where the function will look for adjacent elements. The method will return a list of adjacent elements. Now we can see the output. Working with get_elements_attached. The get_elements_attached method works in the same way as the previous methods. Provide an element and a domain to find attached elements. This method will return a list of elements and their corresponding part. Now we can see the output. Loading and modifying nastran.bdf files. When you load a nastran BDF file into NaxToPy, all the information is organized into N2P card objects, managed through the powerful N2P model input data interface. The get_cards_by_field method allows you to search for data in the file using keywords or specific positions. This makes it easy to access model elements like materials, finite elements, or section properties. Here's an example of how to modify a BDF file. First, the script uses the get_cards_by_field method to locate specific cards in the .bdf file, searching for cards with the keyword CFast at the default position, 0, 0. Next, it assigns the first card of type MAT1 from the model's input data to the variable myMaterial. This links the script to a specific material definition from the .bdf file. Now, we use myMaterial.e to access and print the material's elastic modulus. Initially, it reads the existing value from the .bdf file. The elastic modulus is then updated to 70,000 and the new value is printed to confirm the change. Finally, the script rewrites the updated .bdf file using the rebuild_file method. It saves the modified file in a specified folder while maintaining the original file structure. Advanced functionality. Using NaxToPy makes it easy to search your mesh, generate lists of elements, nodes, and connectors, and dive deep into your structural model. First, the script retrieves all elements from the model and filters them to include only those of type C quad 4, representing quadrilateral finite elements. Next, it fetches the node at index 0 from the model. This node will serve as the reference point for the upcoming analysis. The script then accesses the connectivity data of the selected node, identifying the elements it belongs to. This connectivity is key to understanding the relationships within the mesh. It retrieves all elements that share a face with the connected elements, expanding the scope of analysis to adjacent parts of the mesh. Finally, it collects all nodes that belong to these neighboring elements, ensuring that only nodes from elements where the attribute exists are included. With just a few lines of Python, you can extract meaningful relationships between elements and nodes in your structural model. We hope this video has been helpful. See you in the next tutorial.